So we will start Chapter 5 review. As I said, this week you should get started on learning Chapter 5. And the first part of Chapter 5 is on balancing chemical equation, learning to write chemical equations that represents chemical reactions, and another word also for this is chemical change, right? A chemical change is a chemical reaction, and the chemical equation is showing you what happens during the chemical reaction. And you will see it's also like a recipe that we will use later on to calculate, amounts of reactant or product given the proportions given by those recipe. So I have several skeletal chemical equations, which means they show the formula of reactants. So reactants are on the left side of the arrow. The arrow symbolizes the change, and then to the right side you have the product. So a skeletal equation shows the formulas of reactant and product, but it's not balanced. And to balance means that you want to have the same number of each type of element on both sides of the arrow. And by doing this, by balancing an equation, it satisfies the law of conservation of mass, which says that matter cannot be created nor destroyed. It is just rearranged, and you should retrieve the atoms you started with. You should retrieve them at the end, and so that's why we are doing balancing. So I'll add things here as we do it. So the way I advise to do it, I will show you. So you want to count each type of element on either side of the arrow. And so I like to put the name of, the symbol of the element that you will look at in the middle under the arrow. Let me see, how can I do that? I'll have to do space. Okay. So if you place the elements below the arrow, it shows that, we will count them on both sides. And so, let's see. No. Well, I want just a line. Okay. It's going to be a small line. So let's count them. Oops. On the left. On the left, we have 2 hydrogens. Right, the subscript 2 here belongs to hydrogen. It's always applying to the element before, right? So the 2 is belonging here to hydrogen. So it means we have 2 hydrogens on the left. And on the right, we also have 2 hydrogens from the molecule of water. Let me make this blue so we see what I add more easily. Let's count sulfur. S is for sulfur. Oops. Oh boy. Sulfur. So there is 1 sulfur on the left and 1 sulfur on the right. And then the last element is oxygen. And there is 2 oxygen on the left, right? The subscript 2 here belongs to oxygen. It says you have 2 atoms of oxygen per molecule of oxygen. It's called also oxygen when it's the molecule. On the right, we have 1 oxygen in H2O and 2 oxygens in the SO. Sorry, it looks like it's emails. So that means 3 on the right. I wish these were bigger. Let me see if I can. Well, see if I insert that. Yeah, that's better. Let me just change those because otherwise we can get confused about what it means. Okay, so what you want to do after that is start balancing, which means, starting to make the numbers on both sides of the arrow the same. Here, hydrogen is already kind of balanced for now. We have 2 on the left, 2 on the right, so we can leave it. Sulfur is the same, 1 on the left, 1 on the right. So it's oxygen here that needs balancing. We have 2 on the left and 3 on the right. And when we have 2 and 3, there is no way to make it 2 or 3. You have to do the common multiple of 2 and 3, and that means 6. So that means you will need to multiply by 2 on the right, and then we make this red because we need to understand that we add this, and we will multiply by 3 on the left. So what I add in red here, oops, sorry. What I add in reds are coefficients that I need to put into in front of the reactant and the product in the equation, and so it deals with oxygen. So the 3 on the left that I need to add to make 2 times 3, 6 oxygen on the left, will have to go in front of the molecule that has oxygen in it. So the 3 will have to go here. Does it make sense? So we need to make it 6 oxygen on the left, and so by putting a 3 here in front of O2, we will do 3 times the subscript 2, and it's going to be 6 oxygen. And on the right side, because we have oxygen in 2 molecules, yes, didn't think about that. So we have 2 in one molecule and 1 in the other. So if we multiply by 2 each of them, we will make it 6, right? If you put a 2 here in front of water, it's going to be 2 times the 1 that is implied for the oxygen there. So it's a total of 2 oxygen from water. And if you put another 2 here in front of SO2, it's going to be 2 times the 2 subscript for oxygen. Here it's going to be 4 oxygen. So you will have 4 oxygen from SO2 and 2 oxygen from H2O. So you will get your total of 6. So, becomes 2, times 1, times 1 plus 2 times 2, and that's 6. So this way we have 6 oxygen on the right. So, so when you place coefficient in front of molecules, those coefficients will apply to the whole molecule. And so here on the left side, the 3 only changes the number of oxygen because it's a molecule that has only oxygen in it. But on the right side here, when we placed a 2 in front of water, it changes the number of hydrogens because this multiplies the number of oxygen to 2, but it also multiplies the number of hydrogen, and you do 2 times 2 the subscript of hydrogen, so 2 times 2 is 4. So the number of hydrogen now is not 2 anymore here. It has become, and I guess I will do this, make it crossed. And now it's 4, we said 2 times 2, 4. Oops, I need to stop doing this. Okay, so now it's 4. So we need also to recount the number of sulfur. It's not 1 anymore. because we have a 2 in front of SO2, and now you do the 2 times 1, the subscript of sulfur, and so that means we have 2 sulfurs on, 2 sulfurs on the right now, right? Maybe I should choose a different color for that. Let's make it 2 here and 4 there. Okay? So now we have 4 hydrogens on the right and 2 sulfurs on the right, because we changed the coefficient in front of the 2 molecules. So oxygen is balanced. Here we have 6. Okay. Oh, it's very hard to format this properly. Okay, so we need to balance hydrogen and sulfur. So here, when you will put a coefficient in front of H2S, it will change both. So hopefully this will work out with just one coefficient. We already have a subscript of 2 for hydrogen. So if we want to make it 4, we want to make 2 in front here, right? By doing this, we will do 2 times 2, 4 hydrogens on the left. And this will also change the number of sulfur, because you do 2 times 1 subscript of sulfur, and that's going to be 2 in front of sulfur. So that means these change, and they become so 2 for sulfur, and they become 4 for hydrogen. And let's cross this one. Okay? So let's verify that the count is correct. And for this, it's easier to, so let's recount. So hydrogen. So hydrogen, we have 2 times 2, 4 on the left, and on the right we have again 2 times 2, 4. So 4 on the right. Let's do sulfur. Maybe I should do that on the drawing board. Sulfur, we have 2 sulfurs on the left, and on the right we have 2 sulfurs on the right. So that's good. And then finally oxygen. Let's make sure we have the same number on both sides. So oxygen on the left, there is 3 times 2 here, it's 6. And on the right, there is 2 times 1 plus 2 times 2. So it's 2 plus 4, it's 6. So we have the same number of each element on both sides of the equation, which means it's balanced. So hopefully you could follow that. Does it work well like this, or should I change the way I show this? The best is that you do it on paper at the same time, right? So let's do the next one. And we have nitrogen, and so I'll use that. We have nitrogen, and we have, that's iodine, capital I, right? So let's count the number of nitrogen on the left. On the left, we have only 1 nitrogen. On the right, here the subscript 2 belongs to nitrogen. It says we have 2 nitrogens on the right, 1 on the left. Iodine, we have 3. The subscript 3 here belongs to iodine only, and it says we have 3 iodines on the left. and here on the right there is only one molecule with iodine, and it has 2. So they are both not balanced, so you want to start by balancing nitrogen. Because we have 2 nitrogen on the right and only 1 on the left, so we will want to multiply by 2 on the left, right? Multiply by 2, such that we will have 2 on both sides, and we don't need to change then on the right if we add the times 2 on the left. So that times 2 here will have to go in front of the molecule that has the nitrogen, and here it's, you know, that molecule. So by doing this, we have 2 nitrogens on the left, 2 nitrogens on the right. But by doing this, we also change the number of iodine, because the 2 here is in front of Ni3, and you cannot split the formula of the molecule of the reactant here, and so it will change the number of iodine at the same time than it does the nitrogen. So on the left side, we will need to take into account that now it's 2 times 3, right? 2 times 3, and that's 6. So now we have 6 on the left of the arrow, 6 iodine on the left, and still 2 on the right. So 6 and 2 are multiples, so if you multiply the 2 by 3, you will get 6. So let's multiply the 2 by 3 on the right side, and then we'll have 6 on both sides. So the 3 here will have to go in front of the molecule that has the iodine, and it will go in front like this. And by doing 3I2, you multiply the 3 by the subscript 2, and it's going to be 6 iodine on the right. And I think it's balanced already. This one was easier, right? Let's recount. Make it this. So let's recount the night. Oh, what happened? Oh, sorry. Oh, okay. N. So on the left side we have 2 times 1 nitrogen per Ni3. So that's going to be 2 nitrogen on the left. On the right, we still have 2. And iodine. Iodine, we have 2 times 3, 6 on the left, and here 3 times 2, 6 on the right. So it is balanced. Always verify after you have finished with adding your coefficient to make sure this is balanced. Okay, so let's continue. So this is an example of equation that has ionic compound that contains polyatomic ions. Hopefully you see that. We have OH in parentheses, and there is a 2, subscript 2 here that shows that it's calcium, Ca is calcium, and there is 2, and the OH is hydroxide, the hydroxide polyatomic ion. So there is 2 hydroxide polyatomic ion per calcium ion to make this formula neutral. And if you look on the other side, calcium now is with the nitrate NO3 negative 1. If you look at the list of polyatomic ion, it's NO3 negative 1, and there is 2 NO3 negative 1 per calcium ion. So this shows you have polyatomic ions, and when you are dealing with polyatomic ions, it is very important that you, when you balance, the easiest way to do it is to keep the polyatomic ions as a unit. You will count them as a polyatomic ion. You will not split each element. It's very important to do this, because otherwise it's a nightmare when you try to balance otherwise. So here we will count OH, and if we want to be really precise, it's OH minus 1, right? This OH here is representing the hydroxide ion. So we will count OH minus 1. We will count calcium. Oops, calcium. First, calcium. We'll count, so the NO3, negative 1. Let me add those things. Oops. Oh, I lost the... So you will count NO3. So the 3 is a subscript, and the minus 1 is a superscript, right? The 3 is a subscript that says you have 3 oxygens per nitrogen, and the negative 1 here is the charge. Yes, this one needs to be bold. Okay, so you will count every nitrate. You don't split into oxygens and nitrogens, you count groups of NO3. And then if you look on the left side here, so we have Ca, we have OH, we have NO3, and what is with NO3 in the left side here is H. So that means you will need to count hydrogen also by itself. Okay, so then this should cover every type of element. So let's count the calcium. Let's move it here. So calcium, we have one at this time, one on the left, one on the right, right from this formula, and there. And there is no subscript, you know, after the calcium, so that implies it's an implied one. OH minus the hydroxide ion. There is so the 2 here, you know, around the parentheses belong to the 2 hydroxide. So it means you have 2 hydroxide on the left. And on the right, okay, it's tricky here, but H2O, you need to see it as an H and an OH minus together. It's actually an H plus and an OH minus. Okay, let me change that to say, how can I do this? Okay, let's write it here. H2O, oops, can be seen as H bond OH, right? This doesn't need to be, well, let me make this. Okay, it's important that you see that H2O, you should see it as, okay, won't do that. H2O, you should see it as H bonded to OH, right? So then on the right side, if we count the number of OH, there is 1 in H2O, right? And if we continue with NO3, we have 1 NO3 on the left from HNO3 here, and on the right we have 2 because here it's in parentheses, and the 2 outside the parentheses tells you have 2 of what's inside the parentheses, and it's 2 NO3. And then finally hydrogen. So you do not count the hydrogen that is part of the OH minus when you count hydrogens, right? This is already counted. So the hydrogen here is for the one that is by itself in front of NO3. So it's 1 hydrogen on the left. And on the right, hydrogen is only in water here. And we already counted one of the hydrogen as part of OH. So there is only 1 H also on that side that is bonded to the OH, right? You need to see it this way, so that it's 1 hydrogen on top of the OH. So we counted one OH and then one H, and that makes H2O. I hope it makes sense. Calcium is bonded now. It's not bonded, it's balanced now. The polyatomic ions, OH minus and NO3 minus, are not balanced. And when you have polyatomic ions, so the first thing is to count them as one unit. Do not split their elements. And another key is to start by balancing the polyatomic ion. And here we have no choice because the other elements are already balanced. So, but you always want to start with the polyatomic ions. So let's start with OH minus here. There is 2 on the left, 1 on the right. So you will want to make it 2 on the right so that it's the same on both sides. And so you will multiply by 2 on the right. And the molecule that has the OH is the H2O, right? The other one doesn't have any OH. So the 2 here will have to go in front of water. And by the way, we call them coefficients. So that's the coefficient of 2 here in front of water. And that allows us to say that there is 2 OH now in the right side. And that didn't change the left side. And now let's balance the NO3. We have 1 NO3 on the left, 2 on the right. So we will want to make it 2 on the left so that it's the same. So let's multiply by 2 on the left. And the 2 here, the coefficient 2, will have to go in front of HNO3 because that's the molecule that contains the HNO3, right? So sorry, the NO3, the nitrate. So the 2 will have to go in front of HNO3 because that's where the nitrate ions are. So this way we balance the nitrate. So now we need to recount. The calciums have not changed. There's still 1 and 1 on each side. OH, it's still 2 on the left side, 2 on the right side from the 2 molecules of water. So 2 nitrate on the left, 2 nitrate on the right. But now we have changed the number of hydrogens, right? Because the 2 here is in front of HNO3, and that changes the number of hydrogen. So here now it's not 1 anymore. It's what? It's 2, right? We have 2. Let me make it not like this. Okay, right? So we have 2. Oops, sorry. 2. I just want to put some space. Okay, so we have 2 hydrogens on the left and on the right. We changed the number of hydrogens as well by putting a 2 in front of H2O, right? So it's 2, and you need to see it as HOH. We already counted the 2 OH here, and so we have now 2 H's. So here we also changed that to a 2. So this is crossed, and now it's a 2. Okay? So now we have 2 hydrogens on the right. So it looks like it's all balanced, right? 1 calcium on the left, 1 calcium on the right, 2 OH on the left, 2 OH on the right from the H2O, 2 nitrate on the left, 2 nitrate on the right, 2 H's on the left, and 2 H's on the right from H2O, right? Remember how H2O should be seen as, and maybe I should add this in blue. Okay, so it's you see that equations that have polyatomic ion are actually easy to balance if you follow these tips. Do not split their formulas. Keep them as one unit, and start balancing with the polyatomic ion, and you will see that everything falls into place very easily with equations like that. So they're easy to balance. So here this should be a D. Let me move this so that it's a D. to rearrange that. Are you still able to continue, or do you want me to stop because it's already 11? You know, there's only 2 of you, so you can tell me. Okay. So we can stop and keep the rest for next time. Well, actually, next time is tomorrow. Right? Maybe when we have more people. Oops, I forgot to.